Good morning, I'm Bo Strickland. I'm an instructor at Red Hat, and this morning I am going to give you a taste of training from our System Administration 3 course, where we take experienced Linux administrators and we beef up their networking and their security skills. This morning I would like to give a demonstration of SSH port forwarding. SSH is a Swiss Army knife in any networking setup, and port forwarding allows you to get to traditional plain text protocols by wrapping them in a secure SSH wrapper. Alright, for my demonstration I am working on a machine which is called Desktop 6, which is running Red Hat Enterprise Linux version 6, and I'm going to use it to view a web page that's running on a remote machine which is called the instructor machine. And so if I open my browser and size it down a little bit, I should be able to view instructor and look at the pub directory that is being exported by the web server. As I'm doing this, I'm going to look over my shoulder, as anybody who had access to the network could, by opening up a utility which is called Wireshark. Wireshark, if you're running a white hat, is called a network analyzer. If you're running a black hat, it's called a packet sniffer, but it allows you to monitor network traffic. With it, in my options, I'm going to only capture packets that involve the host instructor and start capturing. And so it looks like instructor is my DNS server. I'm seeing some DNS queries. But as I navigate through, you will see that I'm capturing the packets on the left-hand side. I'm going to restart my capture so I can focus on just the file I'm about to look at, which is the GNU public license. Having done that, if I at least force a reload to force the request, then on the left-hand side I have a collection of all the packets that just traveled on the wire. Let me stop my capture. And one of the nice features of Wireshark is it lets you focus on any individual packet and combine it with its name ring packets to follow a TCP stream. And so you can see in this window that we see the client's request and then the server's response, so that anybody who had access to the network could monitor this web request as well. In order to help protect ourselves, we are now going to set up an SSH tunnel. In order to do this, you need to have an account on the machine that you're connecting to, and let's confirm that I can get in as root on the instructor machine using a standard SSH connection. Providing the right password, I'm on the instructor machine, so I know that I'm able to get there using a standard SSH connection. In order to establish a tunnel, I'm going to make the same type of a connection, but I'm going to say, as a side effect, take my local port 12345 and connect it to instructor's port 80. And this will now establish a local port, which all communication through that port will get tunneled to the instructor's machine's port 80. I need to go ahead and start up my SSH connection. But now then, if I were to restart Wireshark, and authenticate as root, let me set up a capture again with the host instructor and start my capture. If I were to reload this page again, now not talking to the instructor, but instead I'm going to go to the local host port 12345. Why did I choose that port? Well, that's the same port that I arbitrarily chose on the command line as the port that I wanted to use to set up this tunnel. When I make a request of that port, what I'm getting is it is as if I was talking to port 80 on the instructor machine, and so I'm browsing the same material. And I could look at the same copy of the GPL downloaded from that machine, reloading to make sure that I fetch the transfer. But notice that to anyone looking at the traffic, this is now not a web request, but is SSH encapsulated. And if I ask to follow the TCP stream, then it should give you a nice, warm, comfortable feeling inside, not to see the plain text go by, but instead to see the encrypted ciphertext. And so using this technique, you can take any plain text protocol. It doesn't have to be a web request, but it could be, for example, It could be an IMAP server or any traditional plain text protocol and encapsulate it with an SSH tunnel. Now the command line that I use is a little bit laborious, and so there's also a way that you can pre-configure these tunnels. Let me come back to my local machine, clear things so that we're starting over again, and I'm going to edit a SSH client configuration file that lives in your home directory, .sshconfig. I'm going to say for any host, any connection to the host instructor. Let me give myself a shortcut by saying I always want to connect as the user root. At this point, I'm going to need to refresh my memory by pulling up the sshconfig man page, because the syntax is a little bit different, but this is the man page that talks about all the different configuration that can be placed in this config file. If I search for listen or local, then I find the local forwarding. And looking through this, it looks like there are two arguments. The first is the local port, the second is the host and the binding port. And so I'm going to take the local port, 12345, and set it to be instructors port 80. It ends up you can do multiple of these. I'm going to take the port 12346 and set it up to be localhost 631, the well-known port of the CUPS web administration service. Realize that when I am using the term localhost, this is now interpreted in the context of the remote machine. And so by using this, I'm going to take a service which is usually only available on the instructor machine's localhost and make it available to me locally as well. So we have used SSH to connect to the remote machine. However, the command line that we use to connect to it is a little bit laborious. And so as a next step, we can pre-configure these encapsulated connections by editing a file that is called the .sshconfig file. This is a configuration file for the SSH client. Within it, for a particular host that we're connecting to, such as the host instructor, I'm going to say that whenever I connect to a machine of hostname instructor, I'll give myself a shortcut as the user root. I am then going to pull up the sshconfig man page. And this is to refresh my memory for how I need to set up the encrypted connection, because it is a little bit different syntax. Searching on the word local, I'm coming up with local forward and finding out that I need to have two arguments after that. The port that I want to use to anchor the connection, and the machine and the remote port I'm connecting to. Knowing that, let me set up a local forward for the port 12345 to be the instructor's port 80, much like we just did. I'm also, however, going to set up a second port, 12346, to connect to localhost 631. Remembering that when I use the term localhost, this is now in the context of the machine that I'm shelling into. And so it will be localhost on the instructor's machine, not my local machine. 631 is the well-known port of the CUPS administration service web interface, and so I'm going to take a service that would normally only be available to me locally on the instructor machine and connect to it locally. Having done that, SSH can be persnickety about its permissions on the config file, so I'm going to lock it down, and let me now just say SSH to the machine instructor. Now I'll cat that config file so you can keep that configuration in mind. And SSHing into instructor, I'm now going to authenticate myself, but this configuration has also taken effect as well. And so I should be able to connect to my local host port 12345, much as I just did, and get to the instructor's web server. Or I should be able to connect to the port 12346 locally on my machine and get to the CUPS web administration interface on the remote machine. And so what I've hoped to show you today is that SSH, not only is it a way to access remote machines interactively or run commands, but it's also a way to encapsulate connections to traditional plaintext protocols, wrapping them in an encrypted layer so that any service can gain the benefits of SSH's encryption.